All right, last video for this unit. In this one, we're going to talk about the triangle inequality theorem, as well as a little bit about the Pythagorean theorem. Okay, we're just going to go ahead and jump right into it. We're going to start off here with the triangle inequality theorem. This is part of your notes. But basically what this one says is that the sum of any two side lengths of a triangle has to be greater than the third side length. And if it's not, then it's not going to be a triangle. Okay, so triangle inequality theorem, the sum of any two side lengths of a triangle is greater than the third side. If it's not greater, then it's not a triangle. So this first question, we're given these three side lengths here. And my strategy for doing these is I take the two smallest angles or the two smallest lengths, add them together and see if they're bigger than the largest length. So I'm going to write that down, and then you need to copy that into your notebook. All right, so here's our strategy. Add the two smallest angles together and see if their sum is greater than the largest length. So for this first one, I'm going to do this first one in blue. We have 4 plus 8. And that's equal to 12. 12 is greater than 10. So this one is a triangle. Okay, that's how you're going to do each one of these. The second one, the two smallest are right here, so they have to be bigger than the 18. 7 plus 9 is 16. 16 is less than 18. I'm going to rewrite this a different way. The question mark here, we need to figure out, okay, is the sum greater than the third angle? And the answer is no for this specific one. Okay, that's what all this information here is. Okay, the two smallest, we have a 5 and a 3. So I'm just going to do 5 plus 3 equals 8. Is 8 bigger than 5? Yes, it is. So in this case, these three sides do make a triangle. So that's what we use this for. We just use the triangle inequality theorem to figure out whether or not this makes a triangle. Okay. Here's some shorthands. I actually wrote it out and solved. But the shorthand for each one of these would be this right here. All it's saying is that, like this one right here, the first one, AB plus BC is larger than AC. So here's a question that we just answered. Can a triangle have these given side lengths? We already answered that. Okay, so this one right here, you're going to be asked this quite a bit. It says, what could the third side be? So there's going to be a range of values that allow us to make up this third side. So really the easiest way to do this is to set up an inequality like we did with stuff from Algebra 1. Okay, so inequality here, what we're saying is that, okay, this 12 is the largest side. That's the first scenario. 12 is the largest side. So there, as you can see, there's three scenarios here. Okay, so scenario 1, 12 is the largest side. Okay, in the second scenario, what we are saying is that 10 is the largest side. And then the third scenario, we're saying that X is the largest side. Okay, so we'll run through each one of these. In this first case, with 12 being the largest side, that means that X plus 10 just has to be greater than 12. So when we do this inequality, we take 10 away from both sides, and we get this right here, that x has to be greater than 2. Okay. In the second scenario, where 10 is the largest side, when we take away the 12 on both sides, we get x is negative 2. And this is never going to be true because we can't have negative side lengths. In scenario 3, we have x is the largest side. So if we add the 10 and the 12 together, they have to be bigger than x. So in this specific scenario, 10 plus 12 is 22. X has to be less than the 22. So for every one of these, you're always going to have 3 scenarios, and you're just basing the scenarios on which side is the largest. And then you set up your inequality. And we set up the inequality, we solve to get the x by itself. And that's going to help us to do this final piece here, which we're about to talk about. Okay, so this is the first step to these kinds of problems. And then the second step would be to solve, I guess we could say simplify if we wanted to. So solve / simplify the inequality. And then the third step would be to combine the inequalities that make sense together. Okay, so when we do that, in this first one, we have this x being larger than 2. And in the second one, we have that x is less than 22. So whenever you write your final answer, the inequality has to satisfy this condition here and this condition here. So that's why we have this here. Okay, if we did the same thing to this triangle, again, we would want to make 3 scenarios. Okay, so this will be scenario 1, this will be 2, this will be 3. So scenario 1, where x is the largest side. Okay, if x is the largest side, okay, I'm gonna rewrite this a different way. Oops. If I add the two 15s together, 15 plus 15, okay, these have to be bigger than the x if x is the largest side. So I add the 15s together, I get 30. X has to be less than 30. Okay. For the second scenario, scenario number 2, where this 15 is the largest side, 2 and 3, I mean, it's going to be the same scenario. So where 15 is the largest side, the 15 is going to come all the way over here. And the other 2 sides, the x plus 15, have to be bigger than 15. Well, that's pretty easy to do. X just has to be greater than 0. Okay, so when I write my final solution, I have to combine this and this. So x is going to be greater than 0, but x also has to be less than 30. Okay, so that's what my final solution would look like. Okay, here's some Pythagorean theorem stuff. With Pythagorean theorem, we know that a squared plus b squared is equal to c squared. And this is all just referring to the sides of the triangle. Okay, so the hypotenuse, we need to do some quick refreshing, some quick labeling. The hypotenuse is always the largest side, or the longest side of a right triangle. The hypotenuse is across from the 90. Okay, and then that makes A a leg and B a leg. Okay, so these are three different scenarios that you could have for a squared plus b squared equals c squared. If you're solving for c, okay, this side here, you're going to take the square root of a squared plus b squared. If you're solving for a is equal to c squared minus b squared. If you're solving for b is equal to c squared minus a squared. Okay. So we're going to be using this quite a bit. I guess we'll go ahead and do this example here. So for this example, they give us A is 6 and C is 10, and they want us to find B. So here's B right here. So when I'm solving for B, you can just use this formula if you wanted to. B is going to be equal to the square root of 10 squared minus 6 squared. So B is equal to 100 minus 36. 100 minus 36 is going to be 64. In this case, B is equal to the number 8. Okay, here's the converse of the Pythagorean theorem. There's three different scenarios. You can either have a right triangle, which is the a squared plus b squared equals c squared. You can have an acute triangle, which is where c squared is less than a squared plus b squared. Or you can have an obtuse triangle, which is where c squared is greater than a squared plus b squared. So with this problem right here, they want us to classify the triangles with these different side lengths by using the Pythagorean theorem. And we have to classify it into one of these three categories. So I'm going to do this 4, 9, and 12. So remember, the hypotenuse is the longest side. So the hypotenuse is always going to be the C. Okay, so, or the longest side is going to be C. So when I write this down, I have 12 squared, and I'm going to put a little question mark here because I need to figure out if I'm going to do this symbol, this one, or the equal sign. And then I have 4 squared plus 9 squared. 12 squared is 144. 4 squared is 16. 9 squared is 81. 144. 16 and 81 is going to be 97. We fill in our symbol. 144 is greater than 97. That falls into this category for obtuse. Okay, so that's how you solve questions like that. I think there's one more topic that we need to cover. We're not going to fill out stuff like this. You're just going to be asked one of these questions on a test. Here's some more examples if you want to work on those. Looks like that's it for the PowerPoint. Now, for our quizzes assignment on a specific one, we have a bunch of questions like this. Okay, do the three side links produce a triangle? Will these three sides form a triangle? Will the line segments form a triangle? So we have some stuff like that. More of it. Here's the range question that we discussed a few moments ago. Here's one that says, what could the length of this side be? So this goes in line with all those. Same with this one. So lots of practice about determining whether or not something is a triangle. Okay, this one's simple. What's a formula for Pythagorean theorem? What does Pythagorean theorem work on? What's the longest side of a right triangle called? Okay, this one wants you to identify the hypotenuse. So I'm just kind of scrolling through this. Okay, these right here, like set this one right here where you have the numbers, you need to determine if it's a right triangle or if it's not. So you just use the Pythagorean theorem for that. Same with this one, use Pythagorean theorem. And then you're using the last example that we did with the inequalities. I believe it was this slide right here. So you're still squaring everything, but in this question, what you're doing is telling me whether or not it's acute, right, or obtuse. So you would just compare the different side links and put it into one of these categories. So that would be the last example that we did. That's pretty much the gist of this guy. That's the last lesson for this unit. So if you have any questions, make sure that you ask them sooner than later. So that way your questions can get answered before the end of the unit assessment. See y'all in the next one.